Good day, my beautiful people. Welcome back to Maths Pro Namibia. Before we start with this lesson, I would like to share a few quotes by some unknown authors. If your attention is divided by added distractions, multiply your mental traction by doing a bit of simple subtraction. And remember, smart is something you become, not something you are. Finally, there is a difference between not knowing and not knowing yet.
So today we are going higher level on a topic that we call differentiation. Now, before we look at any example, I want us to understand, why do we learn differentiation in mathematics? What do we use it for? Remember, in the previous video of vectors, I gave an introduction of trying to always relate your topics to real life. So we are going to try and see and understand how can we really apply differentiation in real life. Now, a good example is in the coffee making process. When we make coffee, what we have is we have some coffee seeds, some type of seeds that we call now coffee. And then when the right amount of pressure or process is applied to this seed, it creates a coffee powder. So you create a coffee powder much thinner. And then when you have that coffee powder now, you put it in a cup. I'm going to try to draw a cup here. Okay, not such a beautiful cup, but something like that. When you put now your coffee powder here and you add hot water to it, you create now coffee that you can drink. So what did you do there? You applied the process of differentiation. So what is the process of differentiation? What is differentiation? Differentiation is the rate of change of one variable with respect to another variable. For example, we have the rate of change of velocity with respect to time. That creates a derivative, or rather you are differentiating when you kind of find the rate of change. Now we have, so that's just an example of how we can apply differentiation, or the process of differentiation in real life, or how it's applied. Now we have some ways that we write the derivative. So when we differentiate, differentiation is the process. So when we differentiate, we create a derivative. When you have a derivative, that is also like a gradient function. So what do we mean by that? When we can find a gradient of a certain, let me say you have a certain curve and then you are given a certain point. If you create a straight line going through that point, you have a tangent. So this tangent, I can find the gradient of that tangent, and to find the gradient of that tangent, I would then need to differentiate this function, and when I differentiate that function, I have a gradient function, and in that gradient function, I then substitute in that differentiated function, which means the gradient function, I then get the gradient. We are going to look at how can we now denote. What do we use to represent a derivative? We can use a symbol like dy dx. This is just the derivative of y with respect to x. We could also say perhaps ds dt. ds dt, that's just the derivative of maybe speed with respect to time. Otherwise, they could just use f prime of x. So here we have what we call, this one is the prime notation. We can use the prime notation, or we can use what we call this. Not quite sure about this, the pronunciation, but I think it's Leibniz notation, the prime notation to denote. So if it means that if we maybe find ourselves needing to find the second derivative, we are just going to say, because this is like d to the power 1 of y, so we can just put a 2 there. We just make this prime twice. So then that's the second derivative of y with respect to x. But here, we're just going to focus on the first derivative. Now we are going to look at what we call differentiating by first principle, or first principle of differentiation. What is the first principle of differentiation? We have a definition for that. We'll make it clear that you should differentiate by first principle, so you need to know the first principle of differentiation. If they don't specify, you can always use your other laws of differentiation. So what is the first principle of differentiation? The derivative of f of x with respect to x, which is denoted f prime of x, is equal the limit as h goes to 0 of f of x plus h minus f of x divided by h, provided that the limit exists. There are various reasons that can lead to the limit not existing. For example, if the one-sided limits are not equal, then that limit won't exist. What do we mean by that? If you have a graph like this, for example, I give you a graph like that and I end there, I say this is 3, and then I give you a graph like that. 2 here and this is 4 there. Okay, find the limit of f of x, which is of that function, as x goes to 3. You will see that the limit as x goes to 3, from the left, you are coming from here, from the left, you are going to be on this graph, right? And as you go there, it gets closer and closer to 2. So you will say the limit as x approaches 3 of f of x from the left, which is that, is equal to 2, because it's getting closer and closer to 2, right? But if you look at that function and you find the limit as x approaches 3 from the right, meaning from this side now, this side, you will see that you are actually here on this graph and you are getting closer and closer to 4. So you will see that the limit as x approaches 3 from the right of this function is equal to, or is getting closer and closer to 4. That means the limit as x approaches 3 from the left is not equal to the limit as x approaches 3 from the right. So because 2 is not equal to 4, that means this limit won't exist then. So therefore, we would not use the first principle of differentiation to find this derivative. Here we are going to look at 2 examples. In number 1, the question is saying use the first principle of differentiation to find f prime of x when f of x is equal to 3x squared minus 2x. We also have b for question 1. First thing we will want to know, or we want to remind ourselves of, is the principle itself, the definition. The definition is the limit, or f prime of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. We already have our f of x, right? Which is 3x squared minus 2x. So we want to take note of our important things. And then what else do we need? We need to know what is f of x plus h. I'm going to do this. I'm going to write this with a different marker. So it's f of x plus h. What is that going to be equal to? It just means everywhere we see x, we add h. That's what it means. So we are going to say we have 3x, then at x we add an h, and we put it in brackets just like it's in brackets here. So we put it in brackets, and then we square that. So what did we add there? We just added the brackets and the plus h, right? So, and then we have minus 2, and then it's x again, but then we always add h. Before we come and continue, we want to simplify this. What is this equal to? This is going to be equal to, so f of x plus h is equal to 3x plus h, x plus h, right? Because remember, when I square something, it's the same thing as saying I'm multiplying it by itself. Then we minus 2x plus h. And then we now try to remove the brackets. We are going to do this step by step. We want to make sure we understand everything. So we have 3x plus 3h. What did we do there? We just multiplied through 3 times x, 3 times h. So we have applied the 3 there, but we still have this in brackets. We just included the 3 in the first bracket to be safe. Then we can say this is minus 2x minus 2h. What did we do? We just said negative 2 times x and negative 2 times positive h. Then we come here, we are going to say it's 3x times x. That gives me 3x squared. 3x times positive h is positive 3xh. And then we have 3h times x. It's positive 3xh. Positive 3h times h is positive 3h squared. Then we still have minus 2x minus 2h. positive 3h times h is positive 3h squared. Then we still have minus 2x minus 2h, right? We want to simplify it so that when we come and continue with our calculation, we have something shorter. Then we have, okay, we now try to group the like terms. This is 3x squared. Do we have another 3x squared? We don't. So that's just going to be, it's 3x squared. Then we see that here it's positive 3xh, and it's a like term to positive 3xh. So we can add them together, and that gives you positive 6xh. Then we see we have a positive 3h squared, so it's plus 3h squared, and then we have a minus 2x minus 2h. All those don't have like terms. We can use that. We have simplified f of x plus h. So what do we have? We now come and continue with our calculation. What we have is f prime of x for this, which is what we want in A, is equal to, we know that it's the limit of as h approaches 0 of f of x plus h minus f of x over h, right? So now we know it's limit as h goes to 0. We know now that f of x plus h is this one. So we have it's 3x squared plus 6xh plus 3h squared minus 2x minus 2h. So that's what we have, right? Get rid of this because we don't need this. We have already now found our f of x plus h. Then we see that, okay, that is f of x plus h. Then we see it's minus f of x. What is f of x? It's this one. So it's 3x squared minus 2x. We need to put this in brackets. Why do we do that? So that we can make sure we minus f of x and not just minus part of f of x. Minus the whole f of x, because this is all f of x. So everything is over h. What is that equal to? It's lim as h goes to 0, 3x squared plus 6xh plus 3h squared minus 2x minus 2h. Then we can remove the brackets. This is like saying negative 1. Negative 1 times 3x squared is negative 3x squared. Negative 1 times negative 2 is positive. Negative 1 times negative 2x is positive 2x. Everything over h. Then we can group the like terms again. This is equal to the limit as h goes to 0. Then we see there is positive 3x squared here. And then we see a like term which is negative 3x squared. Positive 3x squared minus 3x squared, gone. Then we go to the next one. We see that we have, okay, we have positive 6xh. Do we have another 6xh elsewhere? No. So we write it down. We are having, okay, before we write anything down, let's first finish grouping the like terms. We see, okay, this is actually positive 6xh, and it doesn't have a like term. So we are done there. And then we go to 3h squared. We see that, okay, this is actually 3h squared, positive 3h squared. It doesn't have a like term. Then we come to negative 2x. Negative 2x and positive 2x are like terms. Negative 2x plus 2x, 0, gone. Then I'm left with this one. It also doesn't have a like term. So then we see that, okay, we are left with 6xh plus 3h squared minus 2h, everything over h, right? Now we see that, okay, what we actually have here now is we have lim as h goes to 0. We factorize because we see they have h in common. So we can factor out h, and then we'll be left with 6x plus 3h minus 2, right? Then we see that, okay, we have that, and that is still everything is over h. Why did we factorize? We wanted to join these terms because we see they have something in common. When we join the terms, we factorize. That way we'll be able to eliminate this h, and because it cancels that. So we're trying to simplify as much as possible. So what do we have left? We have lim as h goes to 0 of 6x plus 3h minus 2. So that's what we have. We can now get rid of this limb as h goes to 0 by letting h to be 0. So it means everywhere I see h, I'm just going to put 0. And then I'm going to be left with 6x plus 3 times 0 minus 2, right? We know that 3 times 0 is just 0. So my answer then to f prime of x, therefore, we can conclude that f prime of x is equal to 6x minus 2. So that's how you're supposed to do A. So that's our derivative for that function by using the first principle. We need this for B. At number 1B, they want you to find the gradient of the tangent at x equal to 2. First of all, I must not forget that f prime of x was 6x minus 2. The answer I got in A. You have a curve, a certain curve, however it looks like. Then you have a certain point, which means maybe x is 2 at that point, and that's where your tangent is. So to get the gradient of that tangent, you want to use the derivative of that original function. The derivative of the function is the gradient function. So for that gradient function gives you the gradient when you know what x is. So therefore, it directs us to the solution, which means we are going to say since f prime of x is equal to 6x minus 2, f prime of 2 will be, so it means I'm just going to say 6, then I put 2 here where the x is, because now I'm substituting 2, because here I substituted x with 2, minus 2. What is that? It's going to be 12 minus 2, which gives me 10. And I'm done. For 2, we are given that we need to find, we are still using the same question, but here we are finding f prime of x when the function is f of x equal to 4 over x. And in B, we are still going to find the gradient of the tangent, but this time is x equal to -1. You will see that some of us, we just confuse ourselves when we see something slightly different. But remember, what you are applying is just the same method. If I know that I need to use lim as h goes to 0 of f of x plus h minus f of x over h, if that's what I know I should use, I'm going to use that regardless of how ugly my function may look like. If I have a fraction, I'm going to apply what the knowledge I have of fraction. So let's see now. So in A, so our solutions here, we want to know first of all, what is our f of x plus h? Our f of x plus h is going to be equal to, remember, f of x is 4 over x, right? So f of x plus h will be 4 over x plus h, right? In A, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x. We just write this down because we don't want to jump any step. The limit as h approaches 0 of, we now know f of x plus h is 4 over x plus h minus f of x, which is 4 over x, everything still over h. That's what we basically have. That may look ugly, but that's the same thing that we have. So we have f of x plus h, which is this, minus f of x over h. That's what we have. Okay? This is going to be 4 over x plus h minus 4 over x. So what we try now to do is we try to solve this, we simplify this on the side just so that when we come and continue here, we just substitute. So what we have here is, we multiply this by x plus h. Why do we do that? Because remember how we simplify fractions. When we have addition or subtraction, we make the denominators the same, and we apply whatever we do to the denominator, we do to the numerator. I'm going to multiply with x, and we do the same thing at the top. Because what you do at the bottom, you do at the top. What does that give you? It gives you 4x over x plus h, and then x there, minus 4x plus 4h over x plus h. What did we do there? We just removed the brackets already. What does that give us? It gives us, now we can try and combine these two. It gives us that this is going to be equal to 4x minus 4x. Remember, this is like in brackets, ne? So it's like negative 1 again. So we can now remove it. You could have also removed it here already and changed this to a plus, but you could keep it and remove it after you have one fraction there as well. So we have negative 1 times 4x is negative 4x, negative 1 times negative 4h over, we are trying to combine them now that they have the same denominator, right? So we have that x plus h, right? Then what is that equal to? That is going to give you 4x minus 4x is gone, right? So what are you left with? I'm left with 4h, negative 4h over x plus h, right? That's what you have. Then remember we said, this was that now, which is this, the numerator now, which is that, divided by h, right? Which means what you have here is, you have limit, I'm going to continue here just for some space, as h approaches 0, this one, so it's of negative 4h over x plus h divided by h, right? But we know that when we have this division, we can change this, because this is like saying divided by h over 1, right? So we can change this division to multiplication and then take this and make a reciprocal of the second fraction. So if this is what we had here, h over 1, we change division to multiplication, make a reciprocal of the second fraction, and then that will give us that. So what is that equal to? That is equal to the limit as h approaches 0 of negative 4h over hx plus h, right? Excuse that. Then what is that going to give you? This h cancels that h, right? So what does that give you? It gives me that I have the limit as h approaches 0 of, I'm just going to continue here, so I'm left with negative 4 on top over x plus h, right? So you could remove this, or you could simply now say, everywhere I see h, I'm going to put 0 now because I want to get rid of the limit, right? So I'm going to put this 0 where I see the h, and then that way I remove the limit, and then I have negative 4 over x times x plus 0, right? What is that? That is going to be negative 4 over x squared, because this is plus nothing, this is just x times x, right? So x times x is just x squared. So this is what I have. So therefore we can conclude that our answer here is, or f prime of x is equal to negative 4 over x squared. So in B, they said find the gradient of the tangent where x is equal to negative 1, right? X is equal to negative 1. That's what we are using. So what is that going to be? Now we know f prime of x is equal to negative 4 over x squared, right? What about f prime of negative 1? F prime of negative 1 is negative 4 over negative 1 squared. And then please don't just assume you know, because sometimes you make this mistake when you're squaring a negative number like this, when it's in brackets, you are going to get a positive. So I have negative 4 over positive 1, which is negative 4. Then you found that this is your gradient. Okay, now we start with looking at some basic differentiation rules. To apply these rules, we are going to have what we call the original function, which is going to be the f of x, and then we have the derivative function, which is now the f prime of x. Now, the first rule that we are going to look at is what we call the power rule. So if we have the power rule, the original function that we can, or that we will need to apply the power rule to, will look like f of x is equal to x to the power n. And to find the derivative of this, or the derivative function of this function, f prime of x is going to be equal to, we are just going to take the n, which is our power, and then we have x, and then from the n that was our power, we subtract 1. So what do we have there? We just took n, we put it here, and then we subtract 1. So that's what we're going to do to apply this rule. In addition, we are going to look at some examples, but before the examples, we also need to kind of incorporate what we call the constant power rule. What does that entail? It means instead of just f of x equal to x to the power n, I have f of x, which is my original function, equal to cx to the power n. What do you have there? You have a constant in addition to what you had there. So I have cx to the power of n, and to get that derivative, f prime of x is going to be equal to, I'm just going to say this constant times the power, then I have x again, and to the power n minus 1. So I'm still going to subtract 1 from the power, but I must first take the power and multiply it with the constant. So that's what it means. What you're basically doing here is applying the same rule, which is the power law, except that I have here a constant, and here you could look at it like I still had a constant there, except that if I say 1 times n, I'm just going to have what I had as a power. But if I had anything else that is not 1, I would get something else. So that's what we are going to apply. So in these following examples, we are just going to look at some examples of the power rule. So we differentiate a and b, and then we will have c. Now, what we are given in f of x is equal to x to the power 3, right? So it means if we are to apply the power law, which means f prime of x will be equal to, remember we said we just take the n, so our n here is 3, so it's just going to be 3x to the power 3 minus 1. That's what we are going to do. So what does that give us? It gives us 3x to the power 2. So that's our derivative for that function. What did you apply? The power law. We took n, we brought it here, and then we have x, and then n minus 1, which we simplify to that. Then in b, we are given f of x is equal to negative 2x to the power of 7. So if we are to find f prime of x, then in this case, remember we said this is like having cx to the power of n, right? So it means I must say c times n and then x to the power n minus 1. So what is my c there? It's negative 2. I multiply that with 7. Then I'm having here x to the power 7 minus 1 because your n is like the 7. So I'm going to simplify this. It gives me negative 14 x to the power of 6. We still need to apply the power law. Just because we see a fraction shouldn't confuse us. If we are to expand this and have something much more with one constant and one power, it means we have a 3 times a 1 over x squared, right? That's what we have. And what is that? This means we have a 3 times an x to the power negative 2. Remember how we changed a negative power to a fraction? When you have a fraction, it means then here we are looking at, or in this example, we are basically having negative power. This is what you're going to be doing when you get or find yourself in a situation where you see a fraction, implying that you have a negative power. So what am I going to do then? Remember, we didn't simplify that because we are high level. We can't be writing things like that. It's 3x to the power negative 2. This is what we're having. So what we can then do is just rewrite this and just have it simpler and just change it so that we have one constant and one power. That way we'll be able to apply our power law easily. It gives you negative 6x to the power negative 3, right? That is your f prime of x. However, I can't give my answer with a negative power because then it's not simplified. So I need to simplify that. I'm going back in reverse, like here this, I want to come to that. So I have a negative 6 times a 1 over x to the power 3, right? Which implies that your final answer is going to be a negative 6 over x to the power of 3. Then you are done. The constant rule, your original function will look like something like f of x is equal to c, meaning c is just any constant, any number. Then I have the derivative f prime of x is going to be equal to 0 always. That's our law. Now to understand this, we can look at an example. Let's say I say differentiate. We're just going to look at one example because it doesn't matter how beautiful or how ugly the constant is. As long as it's a constant, we are going to do the same thing. So I'm going to say differentiate. F of x is equal to 30. I know. By now that I know the law, I already know, at the back of my mind, I already know that my answer f prime of x is going to be 0 because I see a constant. However, I'm going to go a bit into details for this specific one, just so that you understand why it's equal to 0. If you had to look at this and write it or expand it in such a way that you can understand what it was, you can say this is the same thing as saying 30, which is your constant, times 1, right? And what is 1? 1 is the answer I get when I power anything to 0, right? So it means I can say 30 times x to the power 0 if I want the function to have an x, just to make it look like other functions. But I should put a 0 so that it still remains 1 and still doesn't change the value of my function. Now I have 30 times x to the power 0. What did we say we do? If this is my function, which means f of x is equal to 30x to the power 0, what I do to get f prime of x is, I will say 30 times, because it's a constant, which is c, times n, which is 0, and then I have x to the power 0 minus 1, right? What is that equal to? That is 30 times 0 is just 0, times x to the power negative 1, which means I have 0 times 1 over x, right? Which means I have 0 over x, which is 0. I'm going to differentiate, so don't worry about this. It's not part of the question. The question is just differentiate. Then we have a, we have b, and we have c. We are going to apply the laws that we now know and see and explore and see how we can differentiate these functions. So we see that, okay, what we can do is we can say this f prime of x is just going to be equal to, when you find yourself in a situation like this, you differentiate them separately. What you are basically doing is you're just going to differentiate these as f of x, like this is our first function, different second function. So we're just going to differentiate this and add, meaning we find the derivative of 5x, and we find the derivative of 7, and then we add them together. So what is that going to be? The derivative of 5x is going to be, we have 1, right? So if we say 1 minus 1, we have 0. So we have 5x to the power of 0 plus 0, because the derivative of any constant is 0. So what is that? Because anything to the power 0 is 1. So it just means we have 5 times 1, which is just 5. So that is the derivative of our function in A. This function is just the same as that. It's like, just like me giving you a normal constant n. So we have a constant power rule that we need to apply here, because we see a constant, we see a power. So it means if you are to apply the constant power rule, f prime of x will be equal to the constant, which is 3 over 4, times the power, which is 3 over 2, x to the power 3 over 2, the power, minus 1, which is, yes, minus 1. If you want to use, because you see fractions here, you can also already know that I'm just going to say minus 2 over 2, because 1 and 2 over 2 are the same. Why am I saying 2 over 2? Because I see the denominator was 2. So I'm going to simplify this. It's going to be 9 over 8 x to the power. Then I have here 3 over 2 minus 2 over 2. That is just going to be 1. That is just going to be 3 minus 2 is just 1 over 2, right? So I have 9 over 8 x to the power half, right? So that is my f prime of x. However, I can write this as 9 over 8 square root of x, because power half and the square root of that thing is the same thing. The last one we are given, this is going to be the same thing as saying 5 over 2 times 1 over 5x plus 2 to the power of half. That's basically what we have. What does that tell you? Move this fraction and write it as 5 over 2 times 5x plus 2 to the power and negative half, which we can write without these. Just write every step down. Doesn't mean in the exam you need to write all these times and all these details down. Should go through every step. So we have that, right? So what is that equal to? Then I see that, okay, this is like my constant. This is like my variable. So it's like, this is like cx to the power n. So what do I do in this case? I'm just going to say this is going to be 5 over 2 times the power. Remember, we always multiply with the power, right? And then I still have 5x plus 2 to the power, which is n minus 1. Which, remember, we said we can use a 2 over 2 for 1, because we see our denominator is 2. So at the back of our mind, we know that. So what is that going to be? So this is going to be a 5 times negative 1 is negative 5 over 2 times 2 is positive 4, Then I have 5x plus 2 to the power. Negative 1 over 2 minus 2 over 2 is like negative 1 minus 2. So it's negative 3 over 2. So we have a negative 3 over 2 here, right? What is that equal to? We can see that that is basically going to be a negative 5 over 4. Then we see that, okay, this is like saying times, remember, this is like one thing. So it's 1 over 5x plus 2 to the power 3 over 2. That way we remove that negative, right? What is 3 over 2? We know that that's like saying a 3 times a 1 over 2, right? So it means this is just going to be a negative 5 over 4 times 1 over, then we know that we can say square root of, because this is like saying it's 3, this is like saying 5x plus 2 to the power of 3. Then we multiply it with a half, because we multiply the powers. So in the end, this is square root of this 5x plus 2 cubed. That's what we have. What is that equal to? That is just going to give you, this negative 5 will just go there. So it's just negative 5 over 4 square root of 5x plus 2 cubed. That's what you basically have. Just, we are going to look at more laws of differentiation and then more examples.
Take note, when you have to differentiate and a plus or a minus is involved, you use what we call the sum and difference rule, which means if you have, for example, f of x is equal to 5x squared minus 4x, the overall derivative will be the derivative of 5x squared, which is 10x, minus the derivative of 4x, which is going to be 4, implying that your answer will be 10x minus 4. Thank you for watching. More rules and more examples in the next video.